On dividing these two, the quotient you are going to remain it as Q be the quotient and R1 be the remainder. If R3 is equal to 0, then R2 is going to be known as the HCF of the integers A and B. If you are getting 0, the dividend will be the HCF of given two numbers. Any two numbers first you can choose. By choosing that two numbers which is a maximum number, that maximum number will be divided by the minimum number. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the last session, we have learnt about the problems on finding HCF as well as LCM. You were having LCM finding two methods. One is factorization method, another one is division method. And then I have taught you in the last session that how to find out the HCF by factorization method. Now that is the rule 1. So in this session, we are going to learn the topics. What are all the topics as rules to find out the HCM, that is rule 2. And then based on rule 2, some of the problems. And then we are going to have relationship between HCF and then LCM. And then based on that relationship, we are going to have problems and then to find the HCF and then LCM of the fractions. Okay, now let us move on to what do you mean by the rule 2. That means what is the procedure you are going to follow for rule 2. And dear students, rule 2 is also known as division method. Rule 1 is known as factorization method. Now let us look into how the rule 2 procedure. I am going to take the numbers A and B here. Let A and B be any two integers. Without loss of generality, we can assume that A will be lesser than B and greater than 0. Are you getting? Otherwise, B will be greater than A and then you are going to have it as which will be greater than 0. So next will be on dividing B by A. On dividing B by A, B by A, let Q be the quotient. On dividing these two, the quotient you are going to remain it as Q be the quotient and R1 be the remainder. Okay, so this is what you are going to have it a division rule. So here you are going to have the divisor, here dividend will be there. Okay, divisor, here dividend will be there, dividend, and this will be whatever you are going to have it as, that will be a remainder, and this is a quotient. Okay, you are going to have it as that quotient. I am going to call it as, let it be Q. Okay, here. So and then R1, this one, remainder, R1 be the remainder if at all, if R1 is equal to, if this remainder you are going to get it as 0 on dividing the divisor and the dividend. Okay, so if R1 equal to 0, then A divides B. Then HCF of A and B will be A, you are going to call it as HCF of these two integers, HCF of A comma B will be is equal to A itself. Are you getting? This itself is the HCF. Next, suppose if R1, this remainder, if R1 is not equal to 0, if it is not equal to 0, divide A by R1. Okay, that means you are going to divide this by R1, this A by R1 you are going to divide it as, and then let that quotient, whatever you are going to get it as here, the quotient, let it be Q2. Okay, and then R2 will be the remainder. Then after doing that calculation, here you are going to get it as R2, that is a remainder process. Okay, then you are going to have it as, if R2 is equal to 0, then this R1 will be HCF of that integers. HCF of what? A and B. Suppose if you are getting R2 is not equal to 0, what you are going to move? Again you are going to do the process. If R2 is not equal to 0, divide R1 by R2. Procedure will continue on dividing each other. Okay. So and get the quotient as what? Q3, and then remainder will be what? R3. If R3 is equal to 0, then R2 is going to be known as the HCF of the integers A and B. Suppose if R3 is also not equal to 0, continue the same process. Are you getting? Here one example I have taken to make you to understand. So here this process of division method is also known as Euclid's algorithm. Got the non-zero. See, the last non-zero remainder is HCF of A and B. Are you getting this one? So here this process, whatever we are doing, all this process is going to gather known as Euclid's algorithm. They can ask you also the question, so do this by Euclid's algorithm by giving two integers, or find the HCF of two integers by division method also. They can ask you the question in your final examination. You have to remember that. So next we'll be moving on to the example or problem. Find the HCF of 55 and 210 by what? Division method or by Euclid's algorithm. So now I am going to take which is the greatest number, 210. Let me call this one as A and let me call this one as B. Are you getting? 55 is A, 210 is B. So therefore I am going to divide 210 by 55. Okay. So I am going to write like this. Divide 210 by 55. Okay. So I am going to write as like, so divide 210 by 55. So how to divide? This is how you are going to write the procedure. So 55 ones are 55, 55 twos are 110, 55 threes are 165. So 55 fours are, it will go beyond 200. So I can take it as 55 threes are, which is 165. Now if you minus 210 minus 165, isn't it? You are going to do minus. So you are going to get 45. Right? So this is what quotient 1, Q1. This is what Q1 you are going to have. This is what R1. Okay? That's what I have explained in the procedure. R1. Okay? Here you can have quotient Q and then R1 is the remainder. So this is a remainder you are going to have it as. Are you getting this? So here you are going to take this one as, what is that? R1. Now R1 is not equal to 0. It is equal to 45. Now we are going to take it as this 55 and then you are going to divide that 55 by 45. Are you getting? So that for 55 you are going to write as it is. The same algorithm or same procedure we have told here. See here, you can have on dividing B by A, let Q be the quotient and R1 be the remainder. If R1 equal to 0, then HCF of A and B is A itself. If R1 is not equal to 0, see, if R1 not equal to 0, divide A by R1. What you are going to do? Divide A by R1. That's what I am doing, the procedure. So here you can have, see what is that? 45 ones are 45. 45 twos that takes you 90, which cannot be divided. So you are going to have 45 ones are 45. Now you are going to take it as, what is that? You are going to have 55 minus 45 gives you 10. Dear students, observe that this is the remainder R2. Correct? R2 is the remainder. Now is this equal to R2 equal to 0? No. If it is R2 not equal to 0, what you need to do? Again, this R1 will be divided by R2. That's what the algorithm. See here, you are going to have, if R2 equal to 0, then R1 is going to be known as the HCF of A and B. If R2 is not equal to 0, and divide R1 by R2. So divide R1 by R2. So therefore that I am going to take the integer as 45. I am going to divide this one. 10 ones are 10, 10 threes are 30, 10 fours are 40. Correct now? You are going to have it as, so let me take it as here. So what is that? 10. You have to continue as like, okay? I'm showing here 10 Again, you are going to have it as here 45. So 10 fours are as 40. So what is the remainder now? 45 minus 40 is 5 is the remainder. Now this is R3. Now R3 is 0? No. R3 is not 0. What you need to do? Divide R2 by R3. So this is R2. As you know already, this is R2. We have divided R1 by R2 because R1 never equal to 0 there and R2 never equal to 0 there. Here R3 is never equal to 0. So what you are going to do? Divide R2 by R3. So therefore we are going to divide the 10. Here 10 I am going to write it as 5 2s are 10. Now you are going to get it as 0. Now what you are going to get R3? That will be the HCF of these two numbers. Okay, 210. That means whatever you are getting here, dividend, that will be the, if you are getting 0, the dividend will be the HCF of given two numbers. So therefore, HCF of what is that? 55, comma 210 will be is equals to 5. Got this one? So this is the procedure will be. Got? We'll be moving on to the next problem. Still we will be getting clarity how to solve these type of problems. Here I have chosen two numbers. They may ask you for three numbers also. Max to maximum, they will be asking for three numbers. Minimum, they are going to ask it for finding two numbers of the HCF by division method. Got? Next I have taken here, find the HCF of the following numbers by division method. Here I have taken again two number, 104 and 130, which is the largest number. Largest number is 130. Therefore, 104 can divide 130, isn't it? Therefore, I am going to take like 104 as procedure. Here 130 I am going to write inside. So what is that? 104 ones are 104, 104 twos are, it will be 208, 104 threes are, it will go beyond 130, 104 twos are also, it will go beyond, what is that? 130, 208. So 104 ones are 104. Correct na? You are going to have it as. Therefore, you can take here, if you minus 130 minus 104, what it is remaining? You are going to remain with 26, isn't it? So now this is R1. This is not equal to 0. This is not equal to 0. So what you need to do? You are going to divide 104 by 26. Again 104 by 26. Now you are going to have, see 104 is there, this R1 not equal to 0, you are going to divide 104 by 26, you know already 26 fours are, which is 104, now you are going to get it as 0, correct? So therefore, this 26 is the HCF of 104, 130. So we are going to write it as HCF of 104, 130 will be is equals to 26. Got? Next we'll be moving on to the problem. Find the HCF of the following numbers by division method or by Euclid's algorithm. Here they have given it as 45, 90 and 180. Any two numbers first you can choose. By choosing that two numbers which is a maximum number, that maximum number will be divided by the minimum number. And then again you can choose another number by the remainder what it is remaining. Then you can find out HCF of that two number. Here I am going to take it as what? See here I am going to take it as 45 and then 90. Any order you can choose. You can choose any order, not only first number and second number, or you can choose first number and third number also, or you can choose second number and third number also. Here I am going to choose it as what? The first number and the second number. First divide 90 by 45. So how the division method will go? So you are going to write lowest number in the outer side, which is a dividend. Divisor, you are going to write it as 90, correct? And then you know already 45 2s are 90. So if you minus, you are going to get it as 0. So therefore, 45 will be the HCF of 45 and then 90. Now you are going to take that 45. So HCF of 45 90 is equal to 45. Now you are going to choose this 45. Choose this 45 and then find the HCF of that 45 and then 180, which is the remaining number. After finding this HCF, the remaining number is 180. So you are going to choose, this is the HCF of 45 and 90, which is the HCF of 45 and 90. Along with that, a remaining number HCF will be found out. Understood? So therefore, now find HCF of 45 and 180. So you are going to now have it as 45 will be outer, 180 will be inside because it is a bigger number. So you are going to divide 180 by 45. You know already 45 4s are 180. Now it will become 0, 0, isn't it? Now we are going to have, now you can choose. So this will be the HCF of what? 180 and then 45, isn't it? Therefore, all the three number HCF common is what? 45. The common factor you are going to use, that is what the HCF we have learnt in where? In factorization method, the common factor. Therefore, HCF of 45, 90 and then 180 will be is equal to 45. This is your answer. Got? Next problem, find the HCF of the following numbers by division method or Euclid's algorithm 12, 15 and then 24. You can choose any number you want. Okay, here I am going to choose 12 and 24. It is easily divided. So therefore 12 I am going to write outer side, 24 will be inner side because you are going to have inside. So you are going to have 12 2s are 24. So 0. Therefore, HCF of 12 and 24 will be HCF of 12, 24 will be is equal to 12. Now find which HCF. Remaining number is what? Remaining number is 15. What is the HCF of 12 and 14? We found out 12. So what you need to do? You are going to find out this 12 and this 15 HCF. So now find HCF of 12 and 15. Now you are going to take it as 12. So what is that? 15 you are going to write it as inside. 12 ones are 12 already you know, which will be 3, correct? Now what you are going to do? 3 is a R1, correct? The procedure you are going to write. 3 is a R1. R1 is not equal to 0. It is equal to 3, correct? What you are going to do? This 12 again divided by 3. So therefore, you are going to have it as 12 as 3 4s are 12, which will be 0, 0. Now, which is the last remainder? This 3. That 3 is going to be decided as the HCF of all the three numbers. What is all the three numbers? 12, 15 and then 24. So, HCF of what is that? 12, 15, 24 will be is equal to 3. Whatever it demanding, not only the common you need to choose. Whatever at last you are going to have it is, if you are going to get it as 0, that 3 will be, or here, that number will be what? The HCF of all the three numbers. Here, in this problem, I told the common. Whatever it may be the divisor here, if you are getting 0, we have already found out the HCF. Again, taking that number, remaining number of the HCF we are finding. If that remaining number you are going to get it as 0, that number will be the HCF of all the three numbers. Got? So same as here we have followed. Got? Next we'll be moving on to what? Find the greatest integer which divides 42, 52 and 86, leaving the remainder. Leaving the remainder means what? You are going to minus. Minus the given values with respected integers. That means 42 minus 6, correct? And then you are going to have 52 minus 4, 86 minus 2. So let me do that. So 42 minus 6 gives you 36, right? 36 plus 6 is 42. Next, 52 minus respectively 4. It will gives you 48, isn't it? Again, 86 minus 2 gives you, what is that? 84. Now we are going to find out a greatest integer of these three. How to find out greatest integer? First you are going to choose any two number, then HCF of that two numbers along with the remaining number. So let me find out these. What is that? I am going to take it as 36 and then 48. So 36 the 48 you are going to have it as. So you know already 36 ones are 36. Now we are going to have it as, if you minus 36 from 48, 8 minus 6 is 2, 4 minus 3 is 1, 12 is remaining, correct? But this is R1, this is never equal to 0. What you need to do? Divide 36 from 12. So you are going to divide that 36. So you are going to get the answer 12 3s are 36, which will be 0, right? Now what is the HCF of? HCF of 36 comma 48 will be is equal to what? 12, correct? The last number. Now what you need to find out? That HCF remaining number. What is the remaining number? 84, correct? So therefore finding HCF of 84 and 12. Now we are going to take it as 84, 12, correct? So 12, you know already 12 sevens are 84. So you are going to have 12 will be the HCF of all the three numbers. Therefore, HCF of 36, 48, 84 will be is equal to 12. Got this? Is it that so easy to find out? Leaving the remainder, this you have to know. Leaving the remainder. So we are minusing the given values with the integers and then finding HCF of that three integers. Got? We'll be moving on to the next. Relation between LCM and then HCF. What is the relation you are going to have? Two numbers if it is given. That two numbers I am going to take it as, if A and B are two numbers or two integers, then the product of the LCM and HCF, product of LCM and HCF is equal to product of that two numbers. Product of which two numbers? A and B. Therefore here LCM into HCF, product of LCM, product means what? Multiplication. LCM into HCF is equal to product of given integers A into B. This is what the relation between LCM and then HCF of given two integers. Now here you can bring the form of finding LCM or you can take the form of finding HCF. They can ask you anything to find out by giving any two given numbers or given LCM or given HCF. Okay. So here LCM can be found out by cross multiplying. A into B, HCF will be coming to the denominator, or HCF as it is, if you want to find out HCF, take LCM to the denominator. That means these two will be given. Okay. Any two things will be given, they are going to ask you to find out the other one. That's it. Now let us see the problem how we are going to find by using this formula. So next we'll be having, if the HCF of two numbers is 42, what they have given? Given is HCF of two numbers. HCF of, you can take it as what? HCF of A and B, two numbers. Okay. A and B is equal to what? 42, and their product means what? A into B will be is equals to what? 5 2 9 2 0. find their LCM, correct? So find their LCM means LCM will be is equal to question mark. Now what is the relation you are going to have? Relation will be LCM is A into B by HCF. So write down that. So you are going to have your LCM will be is equal to A into B divided by HCF. So therefore A into B, product of two numbers, they have given what? 52920 divided by what is the HCF? 42, which will give you the number 1260. This is your LCM. Is that so easy? This will be asked for 2 marker. Understood? Any two things will be given. You are going to find out either the LCM or product of numbers or the HCF, right? Let us move on to the next problem. The HCF of two numbers is 16 and their LCM is 160. If one of the number is 64, find the other number. What is the given? Given you are going to have it as HCF of two numbers. Two numbers, which will be is equals to 16, and LCM of two numbers they have given it as 160, and if one of the number, let me call it as let A is equals to, given it as 64, find B. You need to find out B is what. So what is the relation you are going to have? A relation you can write it as, see, what is the relation? LCM into HCF will be is equal to, what is the relation? A into B, isn't it? A into B. So we know already what is LCM and then HCF. Substitute there. What is LCM? LCM will be is equals to 160 into HCF is 16. You can take it as B. I am taking here A. So 160 is equals to 64 into B. Now what you are going to do? This you are going to multiply divided by that. Now which will be is equal to 2560 divided by 64 is equals to B. Now B will be is equals to, so which will be the answer? 40. So B will be having the value or the integer 40, right? This will be also asked for 2 marker. Got? We'll be moving on to the next. Now how to find out the LCM of the fractions. Now till now you have learnt only if the integers are given. Now how to find out if the fraction is given? Fraction means 2 by 3, 3 by 4, 5 by 7, like this. These are all called fractions. If the fractions are given, how to find out the LCM? That I am taking in generally if A by B, comma, C by D, E by F are proper fractions. A proper fractions you are going to have. That means you are going to have decimal point. Then how to find out the LCM of the fractions? You are going to take LCM of the numerator. What are the numerators? A, C and then E. So LCM of numerator A, C, E and then LCM of, okay? And then divided by HCF of denominator. What is that? B, D and then F. So HCF of the denominator B, D and then F. This is a procedure to find out if the proper fractions are given. Now let me take the example. Find the LCM of 1 by 3 A by B. Correct na? A by B, comma, C by D and then E by F. Now what is the formula? Formula is this one. The same we are going to take it as LCM of the numerator. What are the numerator? 1, 5 and 2. How to find out LCM? You know already by factorization method. LCM of 1, 5, 2. Correct? So how we are going to find out? All three are what? Prime. Prime number means it can be divided by itself, isn't it? So that can be product of that 3 numbers. That's it. 1 will be, that is what? 5 as it is. You are going to 1, 2. Again you are going to have it as 2. It's 1, 1, 1. So how we are going to find out? 5 and 2. So LCM of 1, 5, 2 will be is equal to 5 into 2 will be is equals to, what is 5 into 2? 10, correct? So here you are going to have, first find out LCM of 3 and 6 and then 9. So what you are going to have? 3 and 6 HCF. 3 and 6 HCF of 3 and 6. How to find out? So you are going to write it 3, number 6 here. So 3 2s are 6. You are going to have it as 0 and 3 and 6. Now HCF of 3 and then what? 9. So therefore you are going to have 3, 9. By algorithm, Euclid's are 3 3s are 9. So therefore, what is the HCF of? Therefore, here I am writing. Therefore, HCF of 3, 6 and then 9 is equal to 3. Now you need to find out the fraction. What is the formula? LCM will be is equal to, what is that? HCF of, correct? LCM of 1, 5 and 2. 1, 5, 2 and then HCF of 3, 6, 9. So therefore you are going to write it what we have found out. The LCM of is 10 divided by HCF of 3, 6, 9 is 3. This is your answer. Got now how to find out? Next we'll be moving on to find the LCM of 6, 5 and 8. Let me take LCM of 6, 5 and 8 by factorization method. 6, 5 and then 8. What they have given? 6 by 7, A by B, 5 by 14, 8 by 21. So we are going to choose that one as what? So here any 2 which can be 2 3s are 6, correct? 5 as it is, 2 4s are 8. Again you are going to have it as 2. So 3 as it is, 5 as it is, 2. Now these 3 are what? The numbers prime. So 3 1s are 5, 2. Again 5, 1, 1, 2. Again 2, 1, 1, 1, 1. Correct? So therefore, this is what the multiplication. What is that? 2 into LCM of 6, 5, 8 will be is equal to 2 2s are 4, 4 2s are 8. 8 into 5 3s are 15. So the LCM will be is equal to 120. And then HCF. What is the HCF you are going to have? HCF of 7, 14, 21. Obviously you can decide 7 only because you can take any 2 numbers. Let me find out 7 and 14. So 7 2s are 14, 0. Again we are going to take it as 7 and 21. 7 and 21, correct? So 7 3s are 21, which is 0. Therefore, HCF of 7, 14 and then 21 will be is equal to 7. Now we are going to take it as LCM is given by LCM of 6, 5 and 8 divided by HCF of 7, 14, 21, which will be is equal to 120 divided by 7. Got? This is your answer. We'll be moving on to the next problem. Now, how to find out the HCF of the fraction? HCF means ulta. See here, A by B, C by D, E, F be the proper fraction. You are going to have it as your HCF will be is equal to HCF of a numerator's ACE and LCM of the denominator BDF. That's it. Ulta you are going to work. Here don't confuse in this is LCM divided by HCF. If you want to find out the HCF of the numerator divided by LCM of the denominator. Ulta of the LCM. So we'll be taking find the HCF of 8 by 9, 32 by 81 and then 16 by 27. First let me find out the HCF of what is that? 8 and then 32 and then 16. Obviously it will be 8 only because it can divide all. So you are going to have 8 and 32 first, correct? Now if you divide 8 4s are 32. So 0 again divide 8 and 16, correct? So you are going to have 8 2s are 16 will be 0 0. So HCF of 8, 32 and then 16 will be 8, right? Now let us find out the LCM of the denominator. What is that? 9, 81 and then 27. That is a formula. LCM of the denominator. Denominator is 9, 81 and 27. So LCM of what is that? 9, 81 and then 27. Easily you can say here, see, I'm going to write it as 9. By factorization method I'm going to do, which is the number it divide all? 3. So you are going to have it as 3. 3 3s are 9. Correct na? Again you are going to have 3 2s are 6. 3 2s are 6 means 2 will be carrying over 21. 27 3s are. Again you are going to have 3. 9s are 27. Again you can take it as 3. Now 3 1s are 3. 3 9s are 27. 3 3s are 9. Again these are all prime only. 9 is not a prime. You can write it as here 3 1 3 1. Again 3 1 1 1. So what is the LCM? 1 2 3 4. So LCM of 9, 81 and then 27 will be is equal to 3 power 4 will be equal to 81. So therefore you are going to have it as here. What is that? HCF will be is equal to HCF of numerators divided by LCM of denominators, right? So by taking HCF of what is that? 8, 32, 16 divided by LCM of 9, 81, 27. What we found out? We have found out that HCF of 8, 32 and 16 is 8 divided by LCM of 9, 81 and 27 is 81. This is your answer. Right? How to find out what? The LCM of the fractions, HCF of the fractions. Now LCM of the fraction means finding the LCM of the numerator divided by HCF of the denominator. HCF of the fraction means finding the HCF of the numerator, LCM of the denominator. Dear student, if HCF means HCM will come to the numerator. LCM means LCM will be in the upper side. That you have to remember. That is a logic to remember. That's it. Okay. I hope you understood this session. So thank you dear students. In the next session, we'll be also solving some more problems. Not HCF and LCM. We are moving on to solving the complex number and the rational numbers. Thank you dear students.